And the background for my talk here will be a workshop that we held here at GEOS last year in November. We had assessment of the nickel potential in Greenland, and I will show some of the results from that workshop. And I also put Bo Møller Stensgaard as a co-author here because he also contributed tremendous to both the workshop and also this talk here. This BMP GEOS Mineral Assessment Workshop. So we acknowledge BMP for this, and we had two experts, one from USGS, Mike Sientek, and one from Center of Exploration Targeting in Perth, Marco Fiantini. And then we also thank Agnete Steenfeldt and Avanar Resources. Next. So the outline will be, as I say something about the nickel workshop, and talk about the potential nickel mineralization environments in Greenland, and show some of the slides from the stream sediments, what they tell us about nickel, and show some examples on areas for potential of undiscovered nickel deposits. And in the summary, it will be extended summary, also going into a little bit what further developments could be exploited in the future with nickel in Greenland. Next, please. Next again. And yes, this was held in November, as I said, and if you continue, just press a few times. We were a group, a so-called expert panel group of 19 members, and this was led by experts from CIT and USGS, and we were economic and regional geologists and company people, survey people, academic, international, and it was all very lively, and we had all the information and maps out on tables to discuss. And during those 2-3 days, we had talks, and then we went through each area and gave best bits on what potential there were for each area. Say prior to the meeting here, there had been a group at GEOS that had pointed out tracks that were important to go and discuss in further detail at the meeting. Next, please. Yeah, it was a standard 3-part assessment procedure, and could mention that we have had these workshops going on for the last couple of years, looking at other mineral like zinc, lead deposits, and copper. And here in December, we will have again a workshop on wolfram. Please, next. So the background for having the nickel, the focus on nickel last year was, well, if you look at the global distribution, you see, as we heard earlier today, a lot of nickel copper deposits in Canada and in Scandinavia, and in Greenland, you would probably expect, since there's a correlation between the North Atlantic Craton, between these areas here, that you should also expect to find nickel mineralizations, which hasn't really, well, been discovered yet. So there here pointed some PGE. This is the Stensgaard intrusion, and some minor occurrences here in Greenland, which is at the Disco, and this is Kapelholm. So next. So the 3 models we looked at are probably different models to ways to get around it, but we used a model of USGS, and the 3 deposit models we assessed were the komatiite hosted nickel with these examples, and next, sill and dike hosted nickel, so the conduit style, and intrusion hosted nickel, which is not really presented in this talk here, but so here is a cartoon of what represents the komatiite hosted nickel type. So you get different phases of deposition of your immiscible sulfide at various distance from your magma conduit. And this is sulfide, massive sulfide nickel ore from the Norilsk area. So these numbers here were used, means of deposit types, based on the global deposit inventory. So you can see that for the ore tonnage, they increase going from the komatiite type to the Norilsk type, conduit type, and the contact type, whereas the grade decreases. Yeah, next. And next. So, yep, this is sort of the overall mineral system approach, where we look at different scales for targeting nickel. And if you go from left to right, you go from the source to the pathway to the process, taking out the mineral or the nickel through sulfur saturation, and the trap. So this is basically what Tony has talked about this morning. And the way of listing it here is that the ones in red or purple, which is probably difficult to see, but these ones here, they are critical to assess and to certify that they are present in order to get a confirmation that you have a good potential in an area. So here you look at district, camp, and prospect. So just on a few examples, you look at lip size structures for your source. You need high amounts of hot magma generated in the system, and you need some pathways on lithospheric structures, architecture, and magma chambers where you can stagnate your magma. And you have also the need for assimilation, as we heard earlier. And there are different ways to then look in detail here on the geometry of the occurrence. Next. This was the tracks here in blue. The tracks we had predefined prior to the assessment meeting, the workshop. And during the workshop, we redefined some of the track groups, and actually we didn't have time to go into all the areas, but we started in this end and went around and evaluated on the way what was the most important areas to assess. So all these numbers here will correspond to some of the numbers you see in the tables. So for the komatiite style, which this is an example of, we had 25,000 square kilometers of permissive geology, and this is mainly Archean, but also some Paleoproterozoic supercrustal and mafic, ultramafic units. And yeah, reworked Archean as well. And using a combination of mineral deposit models and mineralizing systems for nickel, we used all this information here to put it together. And if you go to the next, yes, and drop that, take the next. So yeah, we have the conduit style here, and these areas here are the ones that we identified as being of potential. So basically the 3 flood basalt provinces in Greenland, 26,000 square kilometers. But if you go on, there's even a much larger area with potential than these outcropped areas, because there are numerous larger magmatic systems and voluminous sill dike swarms throughout Greenland, with no direct link to flood basalts. So we concluded that we needed actually more time to do a proper estimation of this entire area here in red. So we concentrated on the smaller area outlined by the 3 provinces. And those 3 main provinces, I should say again, that's West Greenland and East Greenland, the Palaeogene magmatic province, but also the Mesoproterozoic zigzag dale flood basalt province. Yes. A little bit slide by courtesy of Mike Centek I've borrowed. These are different geometries that you could expect to deposit your sulfides in, and the criteria is that you need it to actually form a deposit. So I think we already been through that with Tony's lecture this morning, so I skip that one and go to the next. So talking about size and compared to the known occurrences, we've heard a lot about different occurrences now. Norilsk is one of the largest, and we have heard about Voisey's Bay, Sudbury, Xinjiang, Mount Keith. The footprints of these here, how does that compare to Greenland? So if you click on. So in scale, what we saw here would be something fitting into this small fraction of West Greenland. So this is a blow-up of the West Greenland igneous province. So from that perspective, there's plenty of room for finding other deposits. And then next again. So stream sediments. So GEOS has had a program since the 80s with Agnete Stensgaard has been the key person in carrying out this. More than 10,000, actually 12,000 samples of stream sediments have been gathered all around Greenland. And sort of to use this to trace potential mineralizations as one obvious tool. So this is how we have used the different XRF analytical methods, but also other methods like, this is maybe too detailed to go into, but neutron activation and ICP-MS work. Yes, so if we look, you can see there are some holes. There's Disco Nusuak is missing from the data set, and also East Greenland, unfortunately. But Agnete took the opportunity to collect samples from Svartenhoek, so that was good. Next. This is the geology of Greenland in a very crude way, and you can see here this is the nickel in the stream sediments, and the cold colors are low values, hot colors are high values, going up to 150 ppm. So the areas that are characterized by high nickel values include mainly the Archean area, the Archean craton, you can see here, and specifically the supercrustal belts, the mafic supercrustal belts that are floating in or are hosted in these areas. But also here Svartenhoek is very high. It's of course part of the basalt province there. Another place is down here at Tasiilaq, Temiamut area in southeast Greenland, which is high. And also up here. So next. So we can compare nickel in stream sediments with rock samples, and the stars are the very high numbers. And there's a pretty good match if you see where you have the high numbers for the stream sediments and the rock samples. This is just to assure that we are actually looking at the geology. It's a representative way of assessing the geology. Next. So based on the geochemistry, could point out certain areas, as I mentioned, the Archean block, both west and east, and here this is one of the supercrustal belts at Semyogasu Charter Group, but also up here at Tasiilaq area and the flood basalt province. Yes, next. If you combine nickel, chrome, copper and titanium, you can make a 4-grid composite map that can be useful. And what is interesting here is that the Archean block is characterized by being high in the green bluish color, so nickel, chrome, and whereas the Kitilidian and the Gardar area down here are high in copper and titanium. So it's very clear way of making a distinction between these areas. So where you have the black colors, that's where you have high values for all four. So this is a way of outlining the craton margins. It's very useful. Next. So there will be some of the outcome of the workshop. This is an example of the Kangerlussuaq area, region 8 here, where we had individual bids. We were the 19 panel members, so each were giving their bids, and there was a consensus made from this. So this is the nickel project of Iqatok, West Greenland by 21st North. And you can see there's the consensus here was actually the highest that we reached at the workshop. One was at 50% percentile confidence interval that there would be an undiscovered nickel deposit. So next. Some of the other komatiite nickel deposits, these are then based on all votes, so the weighted ones. So 2B here is down here in the Bjørnesund area. I'll show a slide on that. And 5 is the Nuuk region, 8 is the Kangerlussuaq, as we talked about, and 15 is the Seelaq area. So generally, the ones in red are the ones that have at least one or more in the 10% confidence. So that means that we are certain to the 10% confidence interval that there would be one undiscovered nickel deposit in the area. Next. So at Bjørnesund, Palaeogene region, this is one of the classical greenstone belts or supercrustal belts. These are really amphibolites, so it's not really greenstones, but and they've been intruded by granodiorites and diorites, and you have here surrounding rocks are the TCG gneisses that have been intruded, the supercrustal belts. As small blips within the supercrustal belts, you'll find examples of ultramafic rocks, and they would have high magnesium, nickel, cobalt, and chrome in some cases. So what we've been looking at in the field is to identify if we could see, for example, real komatiites, but these are fairly high metamorphic rates. It's not very often that we see primary textures in the field, but we have found some traces of komatiites. If you take the next. So this is at Kvanefjord, so in the same area with spinifex textured komatiites, what we interpret as being komatiites, lying in a 2-3 meter unit that can be traced over several kilometers, and it has this what looks like spinifex texture. So there are some positive indications also in Greenland that we have komatiites present. Next. If you look at the chemistry of Ravnstor greenstone belt or supercrustal belt, these komatiites or komatiitic basalts are some of them. These are not really komatiites, they're too low in MgO, but they have nickel contents of up to 3,500 ppm. Another interesting feature which we probably should investigate in more detail is if we really have supercrustal rocks here that have depletion in magnesium. That's usually a good indication that nickel has been lost at some stage, for example to sulfides, if you have low nickel to magnesium. But in this case, we had one at the 10% confidence level for this region here. Yes, take the next. We'll look more into the context style next. Yeah, this is the summary of all the biddings here, and we had 12 different areas, and there are 5 areas that scored high. One was the Minisoc Norite Belt, and the other one is the West Greenland flood basalt province at Disco. So we already we'll hear more in the next talk about the Minisoc project. And yes, take the next. But I will show a little some slides from the Disco Nuussuaq prospect, which is Avanar's license holder. And what we're talking about here is the tertiary province here, and it's an analog probably to Siberian traps. So there are, you have a basin, you have a fault-controlled basin, and you have indications of sulfide segregation. You find sulfide blebs, and you have native iron in some of your lavas. So there are different indications that you have the right criteria. So if you list them up, it would be that you have high magnesium basalts. They are generated from a hot mantle, so high degrees of melting. You have proximity to crustal scale faults and magma conduits. And they intruded into the Cretacic sulfidic country rocks, which are represented by the Atene Formation in the area. And then I have also experienced prolonged episodes of assimilation with siliceous crustal material. So that's sort of and the calcified elements depletion is also seen in the crustal contaminated rocks. So this is comparing scales with Greenland with Norilsk. So you can see it's fairly comparable in size. Yes, please. If you go through these individual criteria, so in more detail, the Vicat Formation is 2 to 5 kilometers of lavas, mainly picrites. There's one very distinct member, is now Yanguit member, which is also variably magnesium-rich, and they have the potential of, due to the high temperatures, of assimilating crust. Yeah, let's go to the next. Yeah, as we have the sulfidic country rocks, and as I mentioned, these are the findings of sulfide or iron, native iron. Native iron here are the open stars, and these are the known eruption sites for contaminated units, I should say. So in red here, this is Vicat and Meligat Formation, and the red units are the units that have been contaminated. So especially this Kokfelt member is interesting. Take the next one. Yeah, so if you look at nickel versus magnesium number, you can see that these Kokfelt contaminated basalts, they have very low nickel, even though they have very high magnesium numbers. So this is a very good indication that sulfide might have been saturated and taken out the nickel. Copper is also low in these ones, and platinum as well. So there will be a presentation later by Henrik showing more the geophysical results. So I would let him tell about the new results on the geophysical. Yes. So in summary, we can say from this workshop, we assessed 16 komatiite type sites or tracks, and 12 tracks considering the conduit type. And if you take the next, next. This was a sort of executive summary of the report that's come out of the workshop. So the statistical mean estimate number of komatiite hosted and conduit type deposit are 4 for each type. There's a lot of mathematics going into this, which I'm not responsible for, but so at the 50% probability, these are estimated to contain 1.9 million tons of nickel. So the best potential for high-grade, low-tonnage deposits are the comatite hosted, located at Ikatok, part of the Nikonasuit complex in West Greenland. The best potential for chondrite type is what we talked about here, the Norad belt east of Manistoc, and the flood basalts in Disco Bay area. And next. But there are plenty of room for other undiscovered deposits. That was one of the main conclusions from the workshop, since we had sort of too little time to go through all the data, but only had to focus on certain areas. If you take next. One example is the Gardar in South Greenland. Next. These are the stream sediment nickel data blown up here. You see there are actually several places where you have very high numbers. And the question is if these high numbers are related to the early Gardar dike swarm, and if that could be an analog to the Voices Bay. So the age is overlapping. So that would be something to look more into. Yes, next. And in East Greenland, there's not a lot of indications that we have reached sulfur saturations most often, and the situation seems to be a little different compared to West Greenland. But if you look at one place, which is the Urbjerg Formation, which is at the base of the inland pile of lavas, so close to the basement. These constitute a distinct array here in magnesium versus nickel. Could indicate that again sulfur saturation was reached and nickel had been lost to a sulfide. But generally you can see palladium, copper. There's a division between sulfur saturated metals and sulfur undersaturated metals. They generally, these rocks here generally from this region generally fall on the sulfur undersaturated side. So there's maybe more to be done there, but yes, next. The zigzagdale basalts, which have equivalent aged dolerites associated with them. This is used to be a very extensive flood basalt province up in North Greenland, stretching maybe all the way over up to the Franklinian. So it's basically tholeiitic continental flood basalts, and they've been erupted through the Independence Fjord group, which are sandstones. So the question is if they could have reached sulfur saturation. We expect that this area is also fed by a plume, and that these dikes here could have been possible feeders. There's not a lot done up there, but there's certainly also an area. If you click one more, there are 3 groups or series in the zigzagdale basalts. So the lower basal series, they define again a low nickel, high magnesium. It's not ultra high, but it's at least distinct. They could have lost nickel to a sulfide, so it's a positive indication, I guess. Next. So last slide, I guess, several ongoing nickel projects in Greenland, and we do see that we have the environments for comatite hosted nickel present, and we also have the environment for chondrite. So, and yeah, we have these 3 established flood basalt provinces, but there are numerous other sills and dikes complexes that could be further investigated. Yeah, so we can say with this workshop we have scratched a little bit in the surface, but and this is also only just a brief summary of some of the results, but the report is now being printed, so you can access it shortly, and you can read more detail about each area that we assessed. Yes, I think that's more or less that. Thank you.